Okay, so we're talking about geometric mean today, and that is how you find altitude or a leg in particular, okay? So when you are trying to solve for an altitude, okay, we call it a heartbeat. Because if you've ever gone to the hospital or seen in a medical class or whatever, the little monitor that controls your heartbeat, it kind of looks like this and it comes in waves. And so your heartbeat problems only works if there is a number or variable on the altitude or inside the figure. Okay, this method also only works if it's two right triangles. So for example, this is not the angle bisector theorem, okay? Some of your angle bisector theorem problems might look similar, but they're not the same. It has to be two right triangles for either this problem or this problem that we're going to talk about in a second, okay? So either one of those, but they have to be right triangles in order for it to work. Okay, so if you are solving for an altitude, okay, how it works is you treat it like a heartbeat. So if you start from left to right, okay, it would be 9 over 6 equals 6 over 4. So it goes 9 over 6 equals 6 over 4. And that's how you would treat it, like a heartbeat. So 9 over 6 equals 6 over 4. So one of your diagonals should always be the same number. Okay, and then as you can see, if you cross multiply, you get 36 equals 36. So this proportion does hold true. However, most of the times there's going to be an x somewhere. So say this had been x instead, it would be 9 over x equals x over 4. And we know x squared equals 36, and the square root of 36 is 6. And voila, it was 6. Okay, so most of the time it's going to have a variable, okay? Okay, so again, you only do the heartbeat if you have a number or a variable associated with your altitude, and it has to be two right triangles. So you're looking for these right angles. There's one, there's two. We have two right triangles, so we can use this method. Okay? I think it was your skills check last time. Like this angle bisector here, if this had been x, you can't do a heartbeat. Okay? Because these are not two right triangles. Okay? So you can only do it if it's two right triangles. This one was angle bisector theorem. Okay, the next one, okay, we call this heartbeat or rabbit, but I'm also going to give you another way of remembering it. But if anybody knows or ever watched Bugs Bunny, has anybody ever watched it? Okay, and you have Elmer Fudd, and you have the carrot, and Bugs Bunny is really fast. Okay, so Bugs Bunny is trying to run around and get the carrot, come back, and hide in the hole before Elmer Fudd can get him, or the carrot. Okay, so he's going to have to take the long way because he doesn't want to go in Elmer Fudd's path. Okay? So he's going to start, and you will start always farthest away from your numbers. Okay? So see how we're heavy in our numbers over here? Okay? So Bugs Bunny is going to run around. He still has to go get his carrot. Okay? Now he has his carrot, so he's going to run back and try to hide in this hole. Okay, so it's going to be this entire side, which is 8, over this side, which is 4, equals, and now he's on his way back, 4 over 2. When you cross multiply, you do get 16 equals 16, so that proportion holds true. Okay, another way to remember it if Elmer Fudd and Bugs Bunny and all that doesn't make any sense to you, is if you throw a boomerang, okay, it curves and then it comes back at you. Okay, so you throw your boomerang and then it comes back. Okay, so again, this method only works if your numbers and variables are on the outside of the triangle. And again, it has to be two right triangles. Okay, so that's the biggest mistake people will make, is they'll try to do this on an angle bisector problem. It has to be two right triangles. Okay, so you have heartbeat. If you're solving for an altitude, it goes up, down, across. If you're solving for a piece of the leg, okay, that means all the numbers need to be on the outside, so this is for a leg. All the numbers have to be on the outside, and it has to be two right triangles. And that is called the rabbit, or the boomerang, whatever one you want to call it. Okay, let's practice. Okay, we're going to ignore the front part, or the first part. We're just going to start practicing. Okay. First one, geometric mean altitude theorem. So the technical definition is, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the length of these two segments. Okay, so basically, anytime you're solving for an altitude or given an altitude, we're using the heartbeat. Okay, so, skip example 1, but example 2, what would be the proportion that I'm setting up? X over 2 equals 2 over 4. So get into the habit of drawing your heartbeat. So it goes up, down, across. X over 2 equals 2 over 4. When we cross multiply, you get 4x equals 4. So what is the value of x? 1, and you're done. Question on that? Okay, turn the page. Okay, we're still using our heartbeat. What is the proportion that we'll use for 3? X over 4 equals 4 over 3. So you have 4 times 4, which is 16, equals 3x. So what does x equal? 16 over 3. You can leave it as a fraction. Okay, number 4. 4 over x equals x over 10. When you cross multiply, what do you get? X squared equals 40. So we need to take the square root of both sides. So you have x equals radical 40. What do we need to do now? Simplify it. So back to simplifying radicals. If you do not simplify, it's wrong. Okay, so how do we simplify this radical? The biggest perfect square that goes evenly into 40. So remember, if you list all your perfect squares off to the side, you're seeing where does 40 fit in your lineup? Right here. And then which one of these goes in evenly into 40? Probably not 36, not 25. Does 16? No. Does 9? So 4 and what? 10. So when you rewrite square root of 4 times the square root of 10, well, what is the square root of 4? 2 radical 10. Okay, so that'll be the trickiest part, I think, is just remembering how to simplify radicals. Okay, is the geometric mean leg theorem. So this is when all the numbers are on the outside and we use what? Rabbit. Okay. Your technical definition is here. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segments of the hypotenuse adjacent to the leg. Those are a lot of words, okay? So just need to know that you use the rabbit when you're looking for a piece of the leg or a leg, okay? So, double right triangle, so we're good to use rabbit. Okay, am I starting on the left side or the right side? Right side. Why the right side? Okay, because you got to go away from all the numbers. Okay, Bugs Bunny's trying to hide. We're going away from everybody. Okay, so I got to go around because I need to get the carrot. Remember, the carrot's going to be at the top. Okay, and then I need to go back, and then Bugs Bunny needs to hide in the hole. Okay, so what's my proportions? 16 over 14 equals 14 over x. This whole thing is already 16, so we don't need to add the x part. Okay, cross multiply. 16x equals what? 196. Divide. What does x equal? 12.25. Okay, am I starting on the left or the right for number 3? The left. Okay, I've got to run around to get to the carrot, then back and hide in the hole. Cliff, what's my proportion? So follow the path. If I run around, what's this side?
16 over 27.
This whole side. Y over 27 equals. Now I gotta go back. Yep.
27 over 16.
Very good. So when you cross multiply, you get 16y equals what? 729. Oops. Divide by 16, what do you get y equal?
45.
Don't forget your units. When it gives you units, make sure you're using them. Okay, Marissa, am I starting on the left or the right for number 4? The left. What would be my proportions? Very good. 8 over y equals y over 2. Cross multiply. 16 equals y squared. Andrew, what do you get for y? 4. Very good. Centimeters, thanks. Chris, do I start on the left or the right for number 5?
Right.
Right. And what would be my proportion?
Y plus 5.
Very good. Y plus 5 over 6 equals
6 over 5.
perfect. This time we have a little bit different, but that's okay. You have 5 times y plus 5 equals 36. 5y plus 25 equals 36. Five y equals 11. So what does y equal? 2.2 feet. Sure. Questions on the rabbit or the boomerang? Okay, that's as hard as it gets. We're going to go through the practice where sometimes you have to do more than one thing together. But the most important thing is what? Well, there's a few, but what are they? 2 right triangles. That's the only time this heartbeat or rabbit boomerang thing ever works. Okay, if it doesn't have right triangles drawn in, don't assume they're right triangles. Okay, make sure that there are 2 right triangles drawn. If we're using heartbeat, what's the case? Finding an altitude. So your numbers or a variable has to be labeled on the altitude. Okay? And then rabbit or boomerangs used when? Finding a leg. And so all your numbers need to be where? On the outside. Okay. Number 1. Okay, we need to look for one variable at a time. Okay, because there's a lot going on. Which one do you guys want to solve for first? Z? Okay. So if I'm solving Z, what method am I using? Heartbeat, because we have an altitude labeled, right? Okay, so I would have 1 over Z equals, okay, so I have 1 over Z equals Z over 2. So I have Z squared equals 2, so what does Z equal? Square root of 2. Oops. So if I'm solving for X, then I'm not looking at Y or Z. So I need to go furthest away from all the numbers and variables, which is going to be which side? The right side. Okay, so if I'm solving for X, what is my ratio going to be? My proportions? 3 over X equals X over 1. So I have X squared equals 3, so what does X equal? Square root of 3. Oh, I could have left it there. Oh well. Ah. Okay, and now I'm looking at Y, so I'm pretending that X and Z aren't there. Am I going to start on the left or the right? The left. Okay, so now I have 1, or sorry, not 1, what do I have? 3 over Y equals Y over, so you might want to use different colors, it can get a little crazy. So I have Y squared equals 6, so what does Y equal? Radical 6. Questions on that? Okay, number 2. If I'm solving for, let's say, X, where am I starting? The right side, because we want to go farthest away from our variable. Okay, so what would be my proportion? 14 over equals, so 14 over X, equals X over 8. So I have X squared equals something. 112. Okay, list out your perfect squares. See if you can simplify. You have 4, 9, 16, 25, 36, 49, 64, 81, 100. Do any of these go in evenly? Work backwards, remember. And what? 7. So what does that simplify to? 4 radical 7. So that's for X. Okay, for Z, what is my ratios?
14 over 3 equals 0.
How'd you get 6?
Because
14 minus 8 is 6. So if this whole piece is 14, and that's 8, then that needs to be 6. So you have 14 over Z equals Z over 6. Z squared equals what? 84. Okay, so I have the square root of 84. See if that can be simplified. So it split up to 4, right, and 21. Okay, and then it simplifies to 2 radical 21. Questions on that? No? Okay. Let's look at number 7. You guys are going to finish these, and when you're done with those, I'll give you your homework, but I want to do 7 together, and then you'll also do number 8 on your own. 7. Okay, if this is a 30, 60, 90, and this one is as well. Okay, across from 30, you currently have x, and that's what is always across from 30. So I have 8 and an x, and then this 30, 60, 90, I just have y and another x. Okay, across from 30 is x, across from 60 is what? X radical 3, and across from 90 is 2x. So what does x equal for this right triangle? 4. So we have x equals 4, so this side would be 4 radical 3. Okay, so we know x equals 4. Okay, across from 30 is what? X. Across from 60 is x radical 3, and across from 90, 2x. So when solving for this right triangle, I don't know what x is. I know what x radical 3 is. So x radical 3 equals 4. How do I solve for x? Divide by radical 3. So I have 4 over radical 3. And then what? Times radical 3 over radical 3. And that's going to give me 4 radical 3 over 3. Now I know what x equals in this right triangle, which in turn is what? Y. So we've had this problem a lot, but it's still very frequently missed because we want to use x from this triangle to be x from this triangle. But really, this triangle, it is x, but in this triangle, it's variable y that is our x. So that's why I encourage you guys to pull apart the triangles. Maybe label your variables with something other than x and y so you don't get confused, and make sure you're solving accordingly. Okay, you're doing 3, 4, 5, 6, and 8. Okay, after you have those, you'll check your answers on the board, and then you'll grab your homework. For number 3, heartbeat. Oh, sorry, it should be. Number 3, I know I just told you guys not to assume, but this should be a right triangle, sorry. Way to pick up on it. Good job. The homework's numbered really weird, but it's just because we took off a lot of the problems.